All right, hello everyone. It's December 26th. All right, let's do this. Best sightseeing pair. Integer array values, where values I represents the value of the ith sightseeing spot. Two sightseeing spot I and j have a distance j minus I between them. The score of a pair of sightseeing spots is this and plus I minus j, or you can say minus j minus I. So the score minus the distance, right? Minus the distance between them. Return the maximum score of a pair of sightseeing spot. Okay. 81526. So sum minus the distance. Sum minus the distance. Yeah, 8 and 5 seems to be pretty solid. Right, we're gonna say the spot is 1 and the spot is 2. Spot is 3 and the spot is 4. One of them will be the answer, right? Or what you can do is, if I say this must, if I have a value that we say it will be involved, right? And then we have bunch, then each one will have a new value, because this distance is 1, so relative to this is actually a 0, right? And then relative to this, because this is 1, 2, this is 3, 1, 2, 3 is minus 1, 1, 2, 3, 4, this is 2. So by doing this, if I go here, I know this is the maximum, right? And then we consider this. Now we say, okay, now we consider this. Or there's no or. interesting. Hold a second. Values I plus I plus minus values j plus j. So we transform 8, 2, 3, 0, 1, 2, 3, and 4. Oh wait, hold on. That's not. It's okay. So, sorry, got this one wrong. Got a little bit excited. And negative. So this, and then we have to minus it. So 1 minus 1 is 0. 2 minus 3. 4. No, 3. This is 4, 2. Okay. So for each one on the first one, I need to find the maximum of this. For each one of this, I need to find the maximum of this. So I can go with the maximum from right to left. Right to left. So basically, this is 2. So the maximum is 5 plus 2 is 7. Basically this and this, right? And then come here, it's still 2, so it's gonna be 9. Alright, and come here, it's 3, and this will be 5. Come here, 8 is gonna be 11. Okay. Alright, so what we now need to do first is get suffix max. And ing has to be different, okay? One max. Oh, I don't even need this. There you go. And then max. Alright, so it's going to be values I plus softmax. And softmax minus I. That'll work. I don't understand. What? Oh, my bad. Negative, minus, minus. Looks right. Target the sum that we want to find can be rearranged to values I plus I plus values j minus j. We go through values from right to left, right, and for each values I, we find its values I plus j. Then we add to it the max values j minus j, where this can be found via suffix max. You wanna try a few more? Just a couple. Yeah, looks solid. Yep. Actually, I forgot to. DP. Somebody has gone through 100 days. Good to go. Well done. Alright, so we're done with this one. I have to go back to this. So yesterday is different ways to put plus and minus. So I'm gonna skip brute force and just check recursion. Well, brute force will work, right? It can work, but it takes some time. Alright, building on the brute force proof, we can say that it has many subproblems that are being solved repeatedly. To understand the redundancy, consider a simple example. Suppose we have lists this and the target is 3. In the brute force approach, we will explore all possible combination of signs. Let's focus on a specific subproblem. Reaching the sum of 2 using the first 4 numbers. Okay. Combination this, right? The sum of the first 2. First 3 is 3. The combination 2. Yeah. In each of these combinations, we encounter the subproblem for reaching a sum of 2 using the first 4 numbers. Isn't that similar to what you're doing here? Right? You are essentially doing the same thing. Basically, the dp is how many different ways, say, from indices 0 to k, right? How many ways are there to make a certain value? Right, so we have 2. Let me think again. Like we say dpij, in this case, yeah, let's say dpij equal to the number of ways to make nums this all the way to I, make this evaluate to j. Right. Of course, j has to plus 1000. It could be negative. Evaluate to j minus 1000. So the answer will be dp n minus 1 target. Right, this will be the answer. Okay. So let's say I have the previous all good. Now I have ith number coming in. How do I do it? So for j, right, we can say for j in range, say 0 all the way to no 2000. Right, for j for this, now we need to say what's dp I j, because the j I know, right, I know what j is, so look to dp I minus 1 j either minus nums I, right, because it's the previous, and it's going to be j minus this, we know how many it is, right, then we add the current, right, or it shall be dp I minus 1 j plus nums I, right, so this is the previous and then plus the current, minus current, right, plus current minus current, and you add them together, right, you add them together. Okay, so here is the interesting part. Where do we start? Well, we start with, now when I is 0, then the only one is just itself, right? The only one is just itself when I is 0. Well, we can definitely try. Is this from yesterday? I believe so. Alright, we need to find how to do a 2D array. Do I just use vector? I guess you can do this. I just need to know the size. What's the size? So this is n. So 2001. Okay. And then alright, so this is, I'll have to go this. Oh! No, I cannot just set a target. If you just set the target, what if... Yeah, I don't think you should set a target. Yeah, but I need +1, so I can store 2000, right? So this is, I can say small equal to. Okay. Plus. If nums if j is equal to, right? If j is equal to num 0, right? Then we say dp j should equal to 1, because you have one way. Everybody else is no way. Actually, it should be j minus 1000. Right, if j minus 1000 is equal to num 0, well, the num is all positive, right? Oh yeah, the num is all positive. But it's fine, I have to go through the whole thing. Alright, whenever it's equal to num 0, and then we'll say that j has at least 1. Alright, now what if I do negative? So I can do here, or j minus 1000 is equal to, I don't know if I can do it this way. Oh, I guess I can. Then we'll say equal to 1. Basically, should we have 2? Right, so, okay, so we go through this. Then we say for m for each I, we'll do this number. Right, now we look the one before, and then we say dpi j should equal to dp I minus 1 j minus 1000 minus nums I. But what if it's not possible? Okay, j could equal to 0. J is 0. That just means it's not possible. Right? Then we can say option 1. So j minus 1000 is large or equal to nums I. If it is, then it should be dpi minus 1 j minus 1000 minus nums I. Otherwise it will be 0. Option 2 is j plus 1000. Minus, no, it's still j minus 1000, j minus 1000 plus nums I. And has to be smaller than n. Smaller or equal to n. Smaller or equal to 2000. Yeah, I think it's the first one. The second one, small equal to, the first one, large equal to 0. So this plus this need to be larger equal to 1000. I think it requires large equal to 0 and smaller equal to n. Yeah, I might as well just change this to this so it's easier to reason. Smaller equal to n. Then we say dpij. And then return let's go to the end, target. Okay. What the hell? Oh, minus. Wait, is it minus or plus 1000? 0 to 2000. So if target is, it should be plus 1000. Should be plus 1000, right? The index is plus 1000. So if we want to go back to the original value, it's in the minus 1000. Okay, go back to original value is minus 1000. But to get the value should be plus 1000. Get back to the original value. Is this index minus 1000? Okay. Oh, whatever you say. Let's try this. That was pretty bad. I don't know why. One, two, three, four, five, right? Target 3. I don't like how this one is done. But I mean, the rows and columns is very different meaning now. So anyway, so we have the 0, which is this. Alright, and then basically we have 0, 1, 2, all the way to 2000, right? And then the one that actually can meet is, because this is the value, I need to use this value minus 1000. Alright, minus 1000. So basically we have 1001 is a 1. Because this value minus 1000, yes. Or we also have 1000. Right, 1000 is also 1. Because this minus 1000, actually no, not 1000. It's 999. Right, that's 1, because 999 is negative 1, so if we put a negative 1, so right, this is this. So now yeah, that's the first round. It's just minus, oh, equal minus equal to negative, okay. Now I equal to 1. Right, I equal to 1. And then j still from 0. So we say we want to add up to this is 0. Right? So to add to this 0, I need, now to add to this j, which is j minus 1000, right, is the value. And j minus 1000, I can either minus nums I, and it has to be larger or equal to 0. Anyway, so if it's 1, I can plus 1, so it can be 2. Minus 1, it can be 0. Alright, or negative 1 plus 1 could be 0, could be negative 2. So it should be this. So in this position, I have j, basically j, let's say j minus 1000. 998. Okay, 998. So j is equal to 998. J minus 1000 is negative 2. Right. Negative 2. Negative 2. Yeah, because minus 1000 is a negative 2. Right? So negative 2. Hold on. J minus 1000 is what? J minus 1000 is the actual value. Minus nums I is the value. Right, but the value need to convert back to index. Value convert to index is plus 1000. So what you mean is we need to remove this and then this, also remove this. Because the index minus 1000 get a value. Value minus the other value, we get a new value. Right, we get a new value. And then this new value need to plus 1000 to give back to the index. So does this one work? Yup, I think this is the one. Number of ways to make to find some j minus 1000, right? To find the sum out using only nums 0 to I plus 1. Here, j minus nums I is derives from j minus 1000 minus nums I plus 1000. It first converts j to target value, right? Computes a new value and finally converts the value back to index. Or run it one more time. Looks solid. Submit this. That is very interesting. One zero. What the hell? I'm not sure. This is weird. Not sure if I add parentheses will make things different. It make things different if I add parentheses? You're kidding me. It's about parentheses. Okay, this is weird. Oh. I still don't know. I think I do. I think I do. C++ fill array with 0? Huh. std dot fill. I'll use this. Row is to fill everybody 0. Oh shoot. Variable length. How about I just say 2001? What's gonna happen? I don't think you can do it. Now what? We can say 2000. We can say this. PP. And say 4. Oh, I think I can say how many m, and each one need to do is this syntax working? I don't know. Oh, I guess the syntax works. Huh. That doesn't work. Why did I got it wrong? Oh, we use accumulate to get a total sum. Okay. Maybe it should be total sum. I don't know. Maybe it should be total sum instead of just 2000. Alright, I'll think about this tomorrow. I do think it probably need to be total sum. Because otherwise it feels right to me. And the index does, yeah, it plus a total sum. Alright, anyway, let's think about this tomorrow. I'll see you guys tomorrow. Adios.